Great. Okay, so ladies and gentlemen, I should probably stop this so that that narrative is captured in its fulsomeness. Okay, we will now proceed to link up these state charts while delivering you to the resplendent buffet in good time here. Here I am going to proceed to hitch up those state charts, okay? And we're going to do so through a variable, as we've noted, because it will be a quantity that is changing over time. It'll be a quantity where we have the hazard rate that comes from smoking contributes to heart disease changing over time. So we're going to go add in to this a variable called smoking specific heart disease hazard rate. Now, if you want to call it something shorter, you're welcome to do so, because not all of you want to use a name like that. But remember, autocomplete is your friend, and it makes a longer name. It'll fill it out for you automatically. Okay, so smoking-specific heart disease hazard rate. We're going to use that, and we're going to set the transition from no heart disease to heart disease to be set by what? Does anyone want to fill in my thinking on this? What's the hazard rate that's going to apply from no heart disease to heart disease? Whence are we going to get it? Okay, it's in the transition. And where will the assumption for that come from? I'll give you a hint. It's something I just added. The variable. That's the hazard rate. It's going to be this thing here. So we're going to say, how am I going to specify this variable? Yes. Beautiful. Beautiful. Yes. This dot smoking. Okay. Awesome. Awesome. And just go down and pick it, and it fills it out in its fulsome glory. I'm surprised Jeff can stomach this after so many boot camps. Okay, ladies and gentlemen, that's step one. So we set this transition to be given by this variable. Now, normally we'd have several in turn. We might multiply hazard rate sort of contributions from each, hazard rate sort of multipliers associated with each. Or we might set up a odds ratio for each and then have an exponent of beta 0 plus beta 1 times some covariate 1 plus beta 2 times covariate 2 as determined by survival analysis or competing risks analysis that feeds into this heart disease. But for now, we're going to go, so we have this set up, and notice this is a smoking specific heart disease hazard rate. How does this relate to this state chart? What do we need to do to complete the thought? Can anyone say? Yes. Yes. So when we're in a never smoker state, what will we need to do? We will need to, what do we do for color to communicate to this little person shape that we were in this state? Well, we set it to be green. We set it. The logic lies before you here. So how are we going to set, if we're a never smoker, how are we going to tell this heart disease state chart that we have a lower chance of going from here to here per year? What can we do? Yes, 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 you got it. You got it. Fill it out. There you go. There it's equal to 0.01. Do we need a semicolon? Yes. Yes, we do. Because we're telling it to do it. Thou shalt make it so. It's an exclamation point. You will do this. Assign this. It's not getting a number back. It's saying, assign it, buddy. Okay. Okay. There we go. Okay. And now, how would we capture it that when we're in a smoker state, we have a higher risk of developing heart disease per year? Yes, we're going to go to current smoker, and what are we going to do here? This dot smoking, fill it out, don't type it. If you type it, you might make a mistake. Autocomplete is your friend. And it's the TA's friend. Okay? Equals, when you're in a current smoker state, you'll have a much higher chance of developing heart disease. I'll say 0.04 hazard rate, chance per year. That means on average 25 years before you develop heart disease as a smoker. So if you're a smoker, you initiate at age 15, perhaps by age 40 you'll start developing heart disease. Okay? Okay? On average, and some will be longer. That's the mean time, 25 years, 1 over 0.04. Okay, and for former smoker, what would we expect? Well, somewhere between the two. Now, in the more fulsome version of this, on which Kurt labored within the past week, there's actually an adjustment of that. Depending how long you've been a former smoker, your rate returns towards the basal rate, towards the rate associated with never smokers. So the idea is if you only had a 2-year bout with smoking, and now as time goes passes, your heart tissue, the idea is it heals just as your lungs recover their more complete function, and your risk goes down. We won't have time to do that. Instead, I'll say this dot smoking, fill it out, hazard rate, and I'm going to put something betwixt them, 0.025, something along those lines. Okay. Could we have this vary by age? You bet, and I'll show you the first step to that before you make your first step to the buffet. Okay? Okay. Ladies and gentlemen, so now the likelihood of them developing heart disease rises if they're a current smoker. Thank you. Grateful. Okay. Ladies and gentlemen, shall we run this model? First, let us build it. Okay? Build completed successfully. Yeah, Aiden did a great thing. Okay. Ladies and gentlemen, build it. Make sure it built successfully. Who needs TA help? The TA, stalwart stewards of any logic, stand ready for thee. Are you ready? Who needs TA help? Okay. This is either a very good sign or a very bad sign. Either people are coming along or people are beyond help.
Or they're ready for lunch.
Or they're ready for Okay, so let's run the model then. If you folks your models are running, let's go run our regular simulation with a smaller population. Here we go. And here we see individuals engaged in behavior. They're going back and forth. This person developed heart disease. Okay? Okay. So we have some development of heart disease. Now, ladies and gentlemen, I'd like to do a few other things before you make your sojourn. to the halls of plenty. Okay? So, are people comfortable with this idea? Do you appreciate what's been done here? We have their current status with respect to smoking affecting the risk that is imposed on them to develop heart disease. The elaboration on which Kurt labored, a version on which I labored before that. You further have a risk extending from each year, each pack year as it were, each year you smoked. So depending on your exposure history, you have a change. In Kurt's, your chance of developing heart disease declines over time in your former smoker state. All these are readily possible. And before this week is out, you'll see some ways in which the key mechanisms be put in place. But before you take that sojourn, I want to do a couple more things. But the most important thing from this session is that we can have different state charts to characterize different concerns associated with a person. We can have each describing the logical dynamics associated with them, but they are not solitudes. We can have interactions going back and forth by which one can depend on the other and vice versa. So we could have smoking status event of heart disease, and we could, if we so wished. And I'd ask you to ponder this. How would we have, let's suppose we want to capture the fact that if someone's diagnosed with heart disease, they're more likely to quit smoking and to stay relapsed. How could we do that? What could we do if we wanted to have this state chart, heart disease, inform the dynamics of smoking? What could we do? Suppose we wanted to impact cessation. What could we do? Could we use a similar strategy? Indeed. We could have the cessation rate that applies, or a cessation rate multiplier that depends on whether or not they have heart disease that factors in their cessation. Maybe if they have heart disease, they have a higher chance per unit time by 20% of quitting smoking. Readily done. You can have these bidirectional interactions, but still each of these is not a solitude, but it characterizes the concern-specific dynamics associated with smoking on the one hand, heart disease on the other, without forcing us to grapple with all possible combinations, which is a feature of aggregate models with which you need to contend if you're building on, say, an aggregate system dynamics framework. Question.
So you can imagine that as you add variables, it starts getting confusing to keep track of what they're linked to. Is there a quick place to, if say, take a look at that smoking specific heart disease hazard rate, and then say, okay, what is it linked to? Without having to click for each state.
Yeah. Good. Great question. And indeed, for many stakeholders, it would be reassuring if they could look at this. To elicit understanding from stakeholders, making model transparent is valuable. And if we could have some way of communicating, putting aside the vagaries that's captured in a variable or some conditional expression, if I'm in this state, do this, use this, otherwise that. Putting aside the vagaries of how it's captured, it would be nice if we knew what was captured, like that the presence of heart disease is affected by your smoking status, right? You're likely developing heart disease is affected by your smoking status. And in any logic, we do this with models, not infrequently, in an informal way. The answer is there's not a, in my view, it's inadequate for the task, but it's certainly a lot better than nothing. We'll go down here to the palette. We will go down to this area for presentation. And what we'll often do is do something like we will draw a line from this to this. We will, sometimes I will actually go and put an arrowhead on it. And I don't know that there's no declarative way for saying that there's an arrow here, but you can put a little sort of arrow angle thing, and we'll show, okay, this affects that, this affects that, this affects that rate of transition, using these kind of visual elements. And that communicates kind of what depends on what, so that we visually can have a high-level understanding of those dependencies. But this is not enabled or enforced by the framework. We have actually suggested in the past to AnyLogic that they do capture this in some visually transparent way, just as in a system dynamics model. When you see a flow that depends on several things, there are links from those things to the flow that it knows about, understands, and can even warn about. Like, there shouldn't be one because you're not using it, or there should be one and I don't see that link. Right now we use these kind of visual elements in the presentation to indicate that for many of our models. But there's no denying that sometimes it can get a little bit messy. What we often will do is we will put these mechanisms that capture things over to the left-hand side so they're only visible for those who wish to see them in the model, and by default when you open it, you don't see them staring at you in the face. The alternative argument is you keep them close to the state chart that they modify, or the transition that they modify to communicate that that they're associated with this. And I myself kind of go back and forth between those two conventions from model to model in a not terribly consistent way. But yeah, it can get a little bit visually messy in ways that are not helpful. You can also set the visibility for some of these, so when you run the model, you don't see them or you do see them, which can again clean up while you're running the model what you see. I don't know if that's helpful, Patricia.
With maybe adding it to the description of the variable too.
Yes. Thank you, Eric. I stand remiss. I should have mentioned that within AnyLogic there's this description field that you can fill in, and often you can add documentation, like where certain assumptions came from what paper an estimate was derived, or from what data set, etc., for model documentation. And before I forget, I should note that up here on Model Tools, you can also go and create documentation for a model. So if you go select the model, you can say create documentation, and it will present for you information. It'll compile information into a document that can be either in Word format or PDF format, etc. That can include many of the details of the models, and that can be useful for summarizing the model. Okay, and indicating the what the assumptions are within the model. So that model documentation can often give you some characterization of the extent of the model, even to the degree of encoding formulas and stuff like that in custom code. So you don't have to go hunt it down. Okay? Okay. There's just a few things left that I want to complete before we begin our visits to the host of plenty. So the first thing is, and I'm going to save this as version 3, and I'm going to, sorry, I just want to make sure, yes, good. I'm going to save this as version 3. For anyone who would like to download my version 3, I will I will provide this on the website right now. Here we go. So excuse me, download my version 2. I'm going to go on to version 3. Here we go. So version 2 is now up on the website under Models Built-in Class, if you wish to partake of it. I am going to go, by the way, when you open that, it will force you to close the old one because they have the same name. That's not to be worried about. Okay, ladies and gentlemen, I'd like to do 2 things here, quickly. One thing is, I'd like to have outputs that summarize the status of the population, the health status of the population. So we're going to have some outputs that count the number of people with heart disease and no heart disease in this population. And I'll leave it as an exercise, unless there's strong demand for it. I'll leave it as an exercise how to do that for smokers. the lessons are exactly the same. They're completely comparable. Mutatis mutandis, as Jeff would say. Okay. Okay. So if we want to count the number of people cross-sectionally who have a certain attribute, there's a very easy way to do that in any logic. And that way of doing it is called statistics. Statistics live in a very particular place in any logic. Wheretofore aren't they located? They're located in the population of interest. So we can ask for the number of those with heart disease in one population or another. We'll have statistics for each. So if you go to the population here, and you go to statistics in the population, you'll notice there's this area called statistics. If it's not open, you can open it here by expanding it. You'll notice it says no items defined yet. I want to count the number of people who are with heart disease and without. Statistics are specifically used for cross-sectional statistics. The number right now who match some attribute. We will see later how we capture what I call flow statistics, things like incidence. How many people in the last week, for example, developed diabetes or developed heart disease? Statistics are for cross-sectional things, like the count of people who currently suffer from heart disease. So we'll have, count. We'll have heart disease prevalent case count. How's that for a name of a statistic? The type. What type do you think this will be? Statistics are recommended by the fact that they're mostly declarative. Okay, we specify them we specify what we want it to do, and it takes care of the details of the how. Do you think this is a count, a sum, or an average, a minimum, or a maximum over the population? Give you a hint. It's called heart disease prevalent case count. Count, ladies and gentlemen. It's a count.
Summing the total number of people?
That's right. And we're summing up the total number of people who match some condition. Hence it says condition there. Now this, ladies and gentlemen, is where the plot thickens. You'll notice that there's a little light bulb there. The light bulb in any logic is designed to alert you to useful facts. And often it points out useful things indeed. This says there's a thing called item. But the wording of this is confusing. It's incompletely clear for many. It says use item, the embedded object. That, ladies and gentlemen, that's geekese. And if I may, I'm gonna translate that to you because it's a dialect with which I enjoy a measure of familiarity. Okay? So what this is saying is we're going to refer to each person in the population as item and term. The first person, we're going to give a condition for them. Do they have heart disease or not? And when we refer to that first person, we'll call them item. Then the next person, we'll refer to them, and they'll be called item. And we'll ask, do they have heart disease or not? Then the next person, we'll refer to them as item and ask if they have heart disease or not. And each time, it's going to be totaling up the count that do. So each person is going to be called item. Well, we're going to specify a rule for that person called item. We're going to specify a rule. Are they eligible to be counted or not? It's going to return true or false. Are they eligible or not to be counted? And we actually specified this rule before, associated with their color, associated with the color of their surrounds. You may not remember it, but we use something called what? Does anyone remember? In state. Awesome. Awesome. That's great. Okay, so we'll use item dot in state. And what do we want to ask? Are they in what state? I'll give you a hint. This is called heart disease prevalent case count. So in what state are we going to look to see if they're located? Yeah, it's not the state of Maine. It's not even the state of New York. It's going to be the state of heart disease. Okay? So let's go back to our statistics here. And we are going to ask, is that person in the heart disease state? But remember, we can't just say heart disease, because there might be dog's heart disease. There might be heart disease in cattle. There might be heart disease in kangaroos. So we're going to say person.heart disease. It's the person's heart disease. Remember we did that before when the morning was yet young? Yeah. So we're going to ask, this is the condition for them to be coming. If they satisfy this criteria, if they satisfy this condition, then they're to be counted, otherwise not. Only if they satisfy this criteria will they be counted. What do you think? Okay. Great. Okay. And next, I'm going to have a similar one called without disease. Should we have this? No, I think I'll skip this. Lunch beckons, and I don't want to delay it unnecessarily. Okay, so having specified that, I'm going to go up and I'm going to create a chart which is updated with that count. But even before we do this, I'd like to show you the power of statistics. Okay? I'd like you to run your model. Well, first of all, build. Build early, build often. And tell me and confirm, does your model say build completed successfully? The TAs stand in the back, ready to serve you. So if anyone needs their help, they just beckon to them. Who needs TA help? Okay, either a very good sign or a very bad one. Okay, so let's run. Okay, not to the faculty club, but here. You'll notice, ladies and gentlemen, that the model's running, but we don't see any evidence of our statistics. But all we have to do is make one click, and we will see what they hath wrought. So if we click on the population here, you'll notice that if we expand this slightly, we actually can see a count. Do you see it there? This is, where did this name, whence did this name come? What's that the name of? Of what is that the name? Yeah, that's the name of the statistic. So the statistics in the population are reported interactively by clicking on this. If you want to see a statistic, you could just click on this population and see the statistics associated with it over time. But we will finish this morning with a simple graph where we will display it. And I'd like you to go to the palette, and I'd like you to go to this analysis area at the palette, and in our final actions of the morning, I'd like you to drag in a time plot, ladies and gentlemen. A time plot. Where is that? It's in this little palette that looks like it's associated with a probability mass function and a cumulative distribution behind it. I'd like you to click on that, and I'd like you to drag in a time plot into main, not into person, but into main. And I'd like you to enlarge it to lend it the dignity of visibility. Okay? Okay. Now I'm keenly aware that I'm standing between you and lunch, and I promise you this will be finished within less than 5 minutes. okay? And potentially less than that. If you are fleet of fingers. Okay, so ladies and gentlemen, I've dragged this in. I'd like to enlarge this size on the left a little bit so we have a bit more room for the numbers. And I'd like you to go and indicate, associated with the properties of this chart, a name. I'm going to say heart disease time plot. I'm going to name it. And what's probably the single most important thing, under the data for that time plot, I would like you to click just like that. And I'd like you to say heart for the title. So I added with this plus button. And I'd like you to give it a title. This is a choice. You could say heart disease prevalent case count. Okay? Okay. And the value here will be the value determined by what? What is it that is determining the case count for us? Ooh, the statistics, and whence do those statistics live? In the population. So we're going to say this dot population dot heart disease prevalent case count. This is actually a function. It doesn't need any information to do its job, so we just have begin paren and end paren. We're calling it. It's something that lives in population. Remember, we added it to the population? And the population is in us. This is me. It's Maine. It's Maine here. Maine is a population, and that is a statistic called heart disease prevalent case count. Are we okay with that? Ladies and gentlemen, the other things you just want to be careful about is this will be updating every year, every 1 year. That's hunky-dory in our case. We're displaying up to 100 samples. That should be fine. We're only going to go 100 years here. And it's going to show a time window of 100 years. That's going to be fine. But often you want to pay attention to these other ones to avoid it scrolling with abandon. Okay, next. And this is probably the final action. I'd like you to build it, make sure it's hunky-dory, make sure it's copacetic, and I'd like you to run it as well. Right-click on simulation and press the run button. Okay? And having run that, where is that chart? Wherein does it live? Where did I put it? I put it up above. Here it is. I put it up above this area here. That is my long-time habit. But you may have other preferences for where your charts live. Perhaps you'd like them to the left or what have you. But the fact remains that this is characterizing the change in the number of individuals with heart disease over time. Do you see that? How is it doing that? The chart is using what to calculate this? The statistics. The statistic that we specified characterized in a declarative way the rule to use for calculating the number of individuals with heart disease. It said count the number of individuals who match this criteria. And it blithely counts them up. If we wanted a prevalence as a fraction, we could have done this as an average, it turns out, and specified 1 for those with heart disease, 0. Otherwise, it would have gotten us a prevalent fraction, as a fraction of the population. If we wanted to sum up the income over the population, we'd say sum and specify item.income if we had an income component. We could compute the average age over the population by choosing average and doing item.age or something along those lines. In short, statistics provide us with a simple to use, declaratively specified. We specify what we want it to compute, not how. And we specify a condition and possibly an expression for things like average, min, max. And it will compute it for us. We can use those statistics interactively when we run the model by clicking on the population here and seeing the value. Or we can display them on a graph that is changing over time and get output. And soon enough in the boot camp, but most assuredly, not before your lunch sojourn,
That's true.
you will learn how to output these statistics to a database and then to input files that can be imported by the likes of Excel, SAS, or Stata, or a platform, ladies and gentlemen, of your choice. Okay? That concludes the morning session. We have before us a resplendent buffet.
We do.
Just as you had the model run, you may now run to the faculty club, and we'll make use of that buffet and repair here to hear the next generation, the power duo of Kurt and Winchell present on the essentials of inter-agent interactions.
And since we've taken you over 12 to 12:15, we're going to say back at 1:15.
Very good.
Okay, guys?
Thank you.
Thank you. Come on. We need to eat. Let's go.
May I rest for a moment?
Take it off, yes.
Okay.
Rest. Sophie and I are going to go up and eat with you.
That's a good idea.
Yeah, it is.
There are some things we could discuss.
Oh, I'm sure there is.
Oh, the microphone died.
It died. We need batteries?
We need, well, here
Oh,
are
you
some
got
batteries.
some?
That,
Okay.
did you hear it, Dad?
Yes.
You couldn't hear it.
I could hear you, but I couldn't hear you down the hallway, so I knew it was dead. If you guys want to walk them over to the faculty club,
Yep.
that would be great. We're in the same room, club room downstairs. Thank you.
I think by casual observation, you may have bigger nails than I.
Yes, and you're spreading water everywhere.
I am?
Yes, all over the counter.
Oh, that's interesting because I didn't touch those.
Wondering if maybe it's your jar? I don't know, there's water everywhere. Do you want to grab some napkins out there?
Whence is that coming from?
Whence is a good question because it seems to be dry underneath of that, but not under that. So I'm wondering if it's your jar. We'll dry everything out. We'll put it on paper.
I'm wondering. Aiden brought these over, so I'm wondering if it might have
leaked.
Like splashed when he was bringing it.
Anything's
Oh, I'm
possible.
sorry to trouble you.
Don't.
Oh, actually, someone brought me. It may have been Aiden
It would
yesterday.
probably.
They brought
Everybody's
me these
making
paper
sure.
towels.
We're going to make sure that these stay underneath so that we can see what's leaking.
Oh
There's your
boy.
replacement. I'll throw these away. Are these old ones too?
I believe those are old.
Okay.
These
ones will be.
Those are. Sorry. Those are the ones in this line were new,
Okay,
but
good. These ones
unless
are old
you
then.
remove those.
Yep. We're good.
So how are we determining what's leaking?
We don't know what's
I want
leaking.
to
That's
ask
why
Aiden because Aiden brought the jars.
I want to put
so,
paper underneath of everything.
So, Aiden, I'd like to thank you for getting these, but I do want to ask a question. We noticed there was a lot of water here.
Really?
Is it
Yes.
possible that this sloshed a bit when you were bringing it over?
Well, it's got a lid on it, so it shouldn't slosh.
That's the thing, and it's a.
So that's why I want to leave everything
Or
on
maybe
paper.
it was. I
That?
filled it too much. Maybe it
Oh,
after
okay.
boiling,
Boiled
it was-
over.
yeah.
So-
Okay, but just to be on the safe side, let's leave everything just on paper.
Can I see how much is in it?
You think he probably emptied? No,
I
it's still
think
full.
Yeah, it was maybe it was more than this when I brought. So
Oh, okay.
Probably it was over
There we
maximum.
go.
Oh,
And
maybe it
it's
was over
drooling.
the maximum
Yeah,
here?
that's why.
Let's
after
not have
boiling,
paper
it
going
has
into
done.
the
Yeah.
shell.
Sorry
Okay.
for that. I
Oh, that's warm.
It would give it a
Yeah, that would
fibrous,
be it.
fibrous tea.
Yeah, very fibrous tea.
Uh,
So what we're gonna do is I'm gonna put some of these just in front, so when it boils,
okay.
we don't have that worry.
Okay, now, who is it that has the key?
That would be you.
She of this?
No, yeah, this
Oh,
room.
we have a master
Young
key.
Chen has a key also, I think. I think I gave her last night the key to this room.
I don't know.
Was it you or Young Chen?
I haven't.
Okay, then it's probably Young Chen.
I have a key so I can lock
Yeah,
for you,
that's
and then
that's
if you
great.
guys are coming at 1:15, I can come back and unlock it for you.
Okay, awesome. That's great. Thank you.
Many talents indeed.
Fun.
I'm pretty sure your tea's not leaking unless you added water to it later.
No, we actually haven't touched it, so.
Nope, that's good. That's why I'm just making sure everything's good. Whoa, that's why.
Oh,
Whoa,
oh my gosh.
that's not cute. That's not cute at all.
That was exciting.
Really? I don't want to come to your house for excitement. Wow. I think there's a lot too much water in there.
So that never happens in my office.
But I don't think you felt it quite that
Yeah,
hard, do you?
I guess. Did you see that?
No, I didn't.
So
I just heard, oh my
it
God.
was like a geyser.
Of hot boiling water.
It was squirting out towards Christine. Fortunately, it fell far short.
I believe you could probably sue
I
the company.
don't
that
think
made
I would
this.
sue the company. I think I would chat with the boys.
Because I think it was filled.
So before you turn it on again, we will empty some of that water at some
Aim it
point.
away from people.
Yeah,
Okay.
I think this should be actually okay. Can we move out of the way and just test it?
You want to try this again?
Yeah. Well, yeah. Can we try it?
Let's do it after lunch.
Okay.
So let's go have some lunch.
Okay. I want to bring along my computer in case I need. And we'll need to lock the doors.